Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk a little bit about how you can use some Python scripts and build just a little bit more on some of the things that we've done already in order to read directories from their inode number. So the record starts out with the inode, then the length of the record, which is normally at least 12 bytes, can be longer. The name length, how big is this name? Recall that this used to be 2 bytes long, however, it was dropped to 1 byte to add the file type into the directory entry, which was sort of a cheat. And then we have our file name, which can be anywhere from 0 to 255 characters long. We also defined a pretty print function that prints out the inode, file type, and file name. And I'm calling a little helper function here called print file type that takes this number, this 1 byte number from here, and translates it. So what does that little helper function look like? It's right here. Print file type, and it will say either unknown, regular, directory, character device, block device, FIFO, socket, or symbolic link. Currently, those are the only values that are defined. If there's something defined in the future, it'll come back and say, I'm unknown with this code. We then define a method called getDirectory. It takes data, which could be a block or several blocks long, depending on how big it is. We set done equal to false, initialize an empty list, and then we have a little counter. And we say, while we're not done, create a directory entry. And then I'm going to check and say, is the inode in that entry 0? Recall that if we set the inode equal to 0, that means that there are some of these hidden values, such as hash directories, etc., checksums, other things that are stored in there. And for our purposes, we really don't need to look at those. We just want to look at the directory entries themselves. Otherwise, if it's a legit entry, we append it to our list, and we add to our pointer the length of this record. If we've gone off the end, we break out of this while loop. Otherwise, we go back and we read another one, and so on. Then we return our list. So it's a pretty basic function. So we've created a new file, ilspy, and it's essentially a lister or ls utility for inodes. And here's our usage function. It says, please give me an image file, offset, and then the inode containing the directory. And I will display it for you. If you didn't give me enough stuff, I will yell at you with my usage. Otherwise, and this should look familiar by now, I'm going to read in my super block, and I'm going to use that in order to create an extended metadata object. Once I've done that, I get my inode location using information from my super block. I call get inode lock. And I calculate my offset using some other things that we've done in the past. I open the file and I seek to the appropriate location. So here's the offset that I calculated from up here plus arg2 was my offset in 512 byte sectors. I read in my data, and I read in one inode. Then I create an inode object from that, and I use my getBlockList function. Then I loop through my block list, and I pull in all of my blocks. And then I say my directory is just get directory on those blocks. It could be just one block depending on the size of your directory, or it could be many. And once I've done that, I will get names, file names from my directory, which is just a list of directory entries, and I'll call pretty print. I will run this on our old friend, the image from our test system, and I will run it on the root directory, which is stored in inode 2. It's a standard place, and sure enough, there you have it. I've printed out the different entries. Most of them are directories, but there are a couple of symbolic links and other files as well. Notice that I have the traditional dot and dot dot entries at the very top, and they both point to inode 2, which in this case is the root directory. It's the top of the pile, after all. Also notice that lost and found is pointing to inode 11, which is another standard place. So if I wanted to look further, perhaps I want to look at etc, I could just take this inode number and I could rerun my script. For that inode, and boom, there you have it. And I could have modified my script. You're certainly welcome to do this if this is what you would prefer, in order to recurse through subdirectories. I just chose not to do so for this simple case. Primarily, I just wanted to show you how you could use some Python scripts in order to load these directory entries from an inode. A couple of quick things that you can do with a script. If I rerun this for my root directory, like so, I can examine some of these subdirectories, and just for grins, let's have a look at this temp directory, which is stored in this inode. So I'm going to go ahead and clear my screen, rerun my command for this directory, and what do you know? Sure enough, I see two files that are stored in my temp directory. Now in this case, these files were not stored as hidden files. They very easily could have been. And notice that these are a process ID and a port for my Xingxi Quan rootkit. So we can see we've added just a little bit more evidence to our pile when we were looking at what exactly happened in this case. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.